So I'll simulate here the first experiment, part A, the conversion of degree Celsius to Fahrenheit temperature. So this is the formula to convert degree Celsius to Fahrenheit. And as an example, we'll consider here decimal value of input degree Celsius 4, and that is same as the hex value. We'll multiply this by 9 divided by 5 and then add with 32. So 32 is in decimal. The result of this will get 39 in decimal, and if you convert this 39 into hex, the result is 27H. So we are expecting 27H result in accumulator after simulation of this program. So we'll assemble this. So no error is there. So we can execute program step by step. So in first instruction 04H is stored in accumulator. We'll execute this instruction. 04H is stored in accumulator. Then 09H is stored in register B. So here we can observe 09H is stored in register B. Then we are multiplying 9 by 4. So the lower 8 bits of result will be stored in accumulator and higher 8 bits are stored in register B. We'll consider only lower 8 bits as it is 8-bit microcontroller. So we'll execute this multiplication instruction. The result lower 8 bits are 24H and in B 00H is stored. After this multiplication, we have to divide this result by 5. So 5 is stored in register B, and then we are performing div operation. So 24 will be divided by 5. So 5 is stored in register B and 24 is divided by 5. The quotient is 7 and remainder is 1. So we are considering only quotient for next part, that is addition of 32 in decimal, that is 20H in hex. So we'll execute this instruction and the final result 27H is in accumulator. So this is the conversion of degree Celsius temperature 4 degrees Celsius into Fahrenheit. Reset this to execute next program. I will delete this. So the part B of this experiment 1 is to convert Fahrenheit temperature into degree Celsius. This is the formula for this conversion, and as an example we'll consider input as a 34 Fahrenheit temperature that we have to convert into degree Celsius. So first we have 34 is in decimal. If you convert into hex, you will get 22H. That is our input that will be stored in accumulator. And 32 is again in decimal, that is converted into hex, and that is 28. So first we will subtract this, multiply it by 5 and then divide the result by 9. If you compute it and calculator, you will get the answer as a 1 in decimal and same in hex. So we'll assemble this program to check whether there is any error or not, and we'll execute it step by step. So in accumulator 22H is stored, in register B 20H is stored. Then we are subtracting A comma B. So the result is stored in accumulator, that is 2H. Then in B we are storing 5 and then we will perform multiplication operation. So result of this multiplication is stored again in accumulator as a lower 8 bits and in register B higher 8 bits. Then we'll divide. To divide this, we'll store 9 in register B. So 9 is stored in register B and perform division operation. The result, that is 1, is stored in accumulator. So this is how you can simulate the different programs in Edsim tool.